Hello viewers, welcome back to another section of my tutorial, and in this video we're going to solve an applied electricity question. So this is a problem in power in AC. So these are the problem codes. It said a single phase motor connected to a 400 volt 50 Hz supply is developing a 10 kilowatts power with efficiency of 84% and a power factor of 0.7 lagging. Calculate A, the input kVA, B, the active and reactive components of the current, and C, the reactive kVA. Kindly watch this video to the end so that you understand the full concepts and also understand how to solve this problem. Don't forget to subscribe if it's your first time visiting this channel. So let's move straight. Now, we were given the active power and the power factor is lagging. But the active power is of efficiency 84%, meaning that not all the active power is working, not all the 10 kilowatts is absorbed, but rather 84% of it, and the rest will be waste. So let's see. Right now we are using the efficient, or the active power is now 84%, that is 0.84% of P, that is 0.8% of the active power. So let's see this. We know that our total power in an AC system is what we call the kVA, and that is what the first question is saying, the input kVA. The input kVA. So if the total kVA, total power inputted into the system, which yielded 10% active power with this efficiency, is given by IV, that is IV, total current times total voltage. But the relationship between S and P, the active power and the total power, is that active power is always equal to the total power cos theta, where this cos theta is the power factor. But now we are saying this is 0.84%, 0.84%. So 0.84%, so P will be equal to 0.84 times S cos theta. Let me make my necessary substitution. My P was 10K. 10 times 10 to the power 3 is equal to 0.84 by my S, where my S I don't know, and we've been asked to find, and cos theta was given as 0.7, which is the same as the power factor. So my S is simply equal to 10,000 all over 0.84 then times 0.7. And what am I getting for that? So I have 10,000 over 0.7 by 0.84, and that is giving me 17.17006, and this is the total watts, the total power. So this, when I want to write it in the kilo, it will be 1 2 3, that is 17 kilo, and this is the volt amperes, because the total, so volt amperes. So we say that the input kVA asked from the A, the input kVA is simply 17 kVA, but this is the actual value, 17006. Now what's the second part of the question? The active and the reactive components of the current. Now before we do that, we need the current itself. So as I wrote, S is equal to IV. I know my V, which is 400 volts. So my I current is simply equal to my 17006 all over 400 voltage. And what am I getting? That will give me the current to be 42.52 amperes. So this is the total current I have in my system, and the current has reactive part and the what? Active part. So the active part is simply multiplying this by the power factor. So we have I cos theta being the active part and I sin theta being the reactive part. So I cos theta, my cos theta is 0.7, so I'll simply multiply 42.52 by 0.7, and this is my I cos theta, or my active current. So 42 times 0.7, and that is giving me 29.76 amperes. Then I come to the reactive power. So reactive current is simply equal to I sin theta. Now how do I get sin theta? I know that cos theta is 0.7, so I'll find cos inverse of 0.7, and I realize that the angle is 45.6. So my theta is 45.6. So I'm going to get my current 42.52 sine my theta 45.6. So what am I getting? That is 42.52. I'm getting 30.37. 30.37. So if you have 42.52 sine 45.6 to give you 30.37, and this is in amperes because it's a current. So I have my active current and my reactive current. Now let's see the last question. It says we should find the reactive kVA. Reactive kVA is the reactive power. So reactive power P, we represent it with Q, is equal to my S that is the total current sine theta. Now let's see, this is also given by my reactive current by my total voltage. Take notes. So if you have the reactive current and you multiply by total voltage, you get your reactive power. So what do I get? My 30.37 simply by my 400, which is equal to 400 by 30.37, and that is giving me 12148. 12148. That is VAR, and that is a unit, volt amperes reactive, or 12.148 kilo kVAR. You can still confirm from S sine theta. Let's see. S that will go was 717006, and sine theta here, the theta is sine 45.6. So you can punch 17006 sine 45.6, and that is giving us exactly the same answer. So that is the end. These are kVAR, our reactive current, our active current, and our total input kVA. Thanks for watching. Don't forget to subscribe.